to begin, I actually want you to pause the video and try the prerequisite skills there in A through E. So the directions there are to find the product of each of those expressions. So if you're back, I hope you were able to do A and B very quickly. These are, the result is the difference of two perfect squares. Okay, so the other day we factored difference of two perfect squares. And what I'm trying to get you to see is that anything of the form A plus B times A minus B, the inside-outside terms cancel out, and we're just left with the product of the first terms subtract the product of the last terms. Okay, so when we FOIL, inside, outside, zero out. So hold that thought for a minute. Right now, down in this next example, if I want to, I could write this as radical x squared. But what I should know is that the square and the square root undo each other. They are inverse operations. All right, so just like if I had x and then I added 3, but then I subtracted 3, right, I'd get back to x. So if I perform inverse operations on a value x, I end up, then the inverse operations undo each other and the result is simply x. Okay, so same idea here. If I were to square radical x plus 2, I'm just left with x plus 2. And similarly, if I were to square radical x plus h, I would be left with simply x plus h. So again, if you hold that thought, but if you can understand this, then you're going to do pretty well with the exercises in this section. So this is something that will happen in a section in Calc 1 where you've probably learned in high school how to rationalize the denominator. Okay, and if you had a radical in the denominator, you would multiply top and bottom by something to get rid of the radical in the denominator. But you're going to see that in exercises such as these, if I wanted to be able to simplify this expression, or again, simply write this expression in an equivalent form, right, that has the same value but different appearance, and we talked a lot about this in the last section. When I want to do that, I multiply by 1. And so anytime I'm working with expressions involving a radical, I should immediately think of something called the conjugate. Okay, the conjugate is the exact same expression except the sign in the middle is opposite. All right, and why might I want to use the conjugate? Right? Why might I want this situation? Oh, wait, let me scroll down. Scroll down. Why might I want a situation like that, right? Where actually I'm circling the top one, not the x plus 3. Why would I want this? Okay, because if I use the same a and b, but I just switch the signs, then my inside, outside zero out when I FOIL. So watch what's going to happen then back in this example with using the conjugate. And again, in order for this to be legal, I have to multiply my expression by 1, which means that I can't just multiply by radical x plus 5. That would change the value of the expression. I have to multiply by radical x plus 5 over radical x plus 5 because this, what I just wrote in blue, this value in blue has the value of 1. All right, so I just took my original expression and multiplied it by 1. So anyway, when I go to multiply here, now same advice I had for you in the last section. Don't be so quick to distribute. Okay, in that denominator, leave it in factored form because I'm going to be looking for things to cancel and I have to be in factored form in order to cancel. So I don't want to FOIL in the denominator and multiply that back together. All right, I'm going to leave my denominator just like this. But then in the numerator, if I did FOIL, right, that's the beauty of opposite signs here. When I do FOIL, I am going to, my inside-outside terms will be 0. And I know from the warm-up that radical x times radical x is just x. Inside, outside are 0. Last is minus 25. Therefore, I can cancel, right? I have the same factor of x minus 25 in both the numerator and the denominator. I can cancel out of a product. I cannot cancel out of a sum. All right, so that's something we've talked about in previous videos. So this divides to 1, and my final result is 1 over radical x plus 5. So your Calc 1 teacher is going to expect you to be able to figure out what the conjugate is, right, without help. In this course, I am always going to tell you to multiply, to take the expression, and I'll give you the conjugate. All right, so just like I did here in letter B, where I said, okay, this is the conjugate. I take the expression that was down in the denominator, and I change this sign to opposite. And the reason I'm going to do that is when I multiply by the conjugate here, I get rid of the radical, right? Because I multiply the radical by itself, which leaves me just what's under the radical. That's actually called the radicand, the part that's under the radical. And then inside, outside, 0 out, and I'm left with last. All right, so I do that because then the expression that I'm multiplying, the one that started off with the radical, I'm going to eliminate the radical from that expression. Now, again, in the numerator, don't be quick to distribute. In the numerator, I'm just going to leave that expression 2x times radical x plus 1. Oh, my cursor is sticking again. That has been happening a little bit to me, and I'm not sure why. So bear with me as I'm struggling to get this to right. Okay, so I'm not going to distribute in the numerator. However, in the denominator, when I go to FOIL, right, if I multiply radical x plus 1 times radical x plus 1, I did that in the warm-up. That's just x plus 1. Inside, outside, 0 out. Last would give me minus 1. Well, isn't that convenient? 1 minus 1, that's just 0. And then I can cancel here. X divided by x, right? Because all of this is gone. This is zeroed out. Then I have x divided by x, leaving me with a final answer of 2 times radical x plus 1 plus 1. Students might ask me, can we distribute the 2 now? If you want, right? I'm totally happy with that answer. Or if you distributed the 2, I'd be fine with that answer as well. So I would like you to pause the video and try letter C. So notice in letter C, I gave you the conjugate, okay, the exact same expression, just with the opposite sign. And then I wrote the denominator for you. Do not distribute that H in the denominator. Okay, so please pause the video and try this problem. Okay, so what we saw from the warm-up is that radical x plus h times radical x plus h is just x plus h. Inside, outside, 0 out. And then when I multiply here, radical x times radical x is just x. Conveniently, these cancel. These are gone. Right, so now I have just an h left in the numerator, right? So this h divided by h divided by h is 1. Make sure you put the 1 up there. Sometimes I see students doing problems like this, and they just cross out the h's, and then they circle this as their answer, right? Well, this is in the denominator, right? Don't forget about our upstairs, downstairs concept. Okay, so my final answer is here. And that's it.